So in these first examples, we're trying to find the prime factorization of each integer. Okay, so if we look at number 2, we're trying to prime factorize 20, right? And so we want to think about what are the prime numbers that go into 20. So that list that we talked about is a good list, right? So we want to think about, okay, well, does 2 go in, does 3 go in, does 5 go in, right? We want to kind of keep these prime numbers in mind when we're trying to obtain the prime factorization of a number. Okay, so I want to keep in mind 2, 3, 5, 7, 11, 13, 17, and so forth and so on, right? 19, 23, 29, 31, and so forth, okay? All right, so I always start with 2. So I just ask myself, does 2 go into 20? And it does, right? So it goes in 10 times. So one thing you can do is a little factor tree here. So you can say, okay, well, 2 goes into 20 10 times. Then 2 is prime, so we can include this in our result. Okay, and then 10 is not a prime number, right? It's not on our list, so we need to keep breaking it down. So 10, does 2 go into 10? It sure does. So we can break 10 down to 2 and 5, right? And 2 is a prime number, so we can include that. And so is 5. So we can include that. So this is the prime factorization of 20 is 2 times 2 times 5. And we can write that in exponential form as 2 squared times 5 if we want to. All right. Okay, let's try 100. Okay, so 100 we can break down into a factor tree. So that's 10 times 10. And each of those 10s is 2 times 5, right? So we have 2 2s and 2 5s. So we can write this as 2 times 2 times 5 times 5. Doesn't really matter the order, but I usually write it from lowest to highest, so in ascending order. So 2 squared, 5 squared would be the exponential version of that. All right, so 248. So we can break that down. So 2 goes in 124 times. And 124, 2 goes into that 62 times. And that's also even, right? So remember, 2 goes into every even number. So anytime it's even, you can break it down by 2. And then we get to 31, right, which is a prime number. So that's on our list. So these are the prime factors of 248, right? So it's going to be 2 times 2 times 2 times 31, or you can write it as 2 to the third power, 2 cubed, multiplied by 31. All right, and notice how I meant to mention this before on 100. Sometimes you know factors that go in, and you can start with that when you're making your factor tree. If you don't know, like 248, I'm not as familiar with as I was with 100. So since it was even, it ended in an even number, I just divided by 2, right? And so 248 divided by 2 gives me 124. Then I do 124 divided by 2, and that gives me 62, and so forth and so on, right? So, and sometimes if 2 doesn't go in, you might have to check, does 3 go in, does 5 go in, and so forth, okay? So number 10 and 12, these numbers end in 5, right? So we know that 5 goes into every number that ends in a 5. So I could check, does 3 go in, does 11 or 7 go in? But when it ends in a 5, I know 5 goes in. So that's a good one to check for. And I know since it does end in an odd, 2 won't go in, right? So 2 doesn't go into odd numbers. It's not a divisor or a factor of odd numbers. So I'm going to take 345 and divide it by 5, right? So 345 divided by 5 is 69. And so then 69 doesn't end in a 5, so I know 5 doesn't go in. So then I could check 3. So 69 divided by 3 is 23, okay? And then 23 happens to be a prime number. So this is our prime factorization. 5 times 3 times 23. I'll write it in ascending order. So 3 times 5 times 23. And we can't write it. There's no common bases there, like bases, so we can't use our exponent properties and put them in exponential form. So that's as far as we can go with that one.